Okay, I believe we did question 4 in class, but just in case we don't have it down, here we go. Water tank. It has 1,200 gallons of water in it at time t equals 0. And we see that water is coming into the tank over an 18-hour period at this rate. And water is also being removed from the tank over that same time period at this rate, r of t. To the nearest whole number, how many gallons of water are in the tank at time t equals 18? Okay, so if we want the number of gallons at the 18th minute, that's going to, or 18th hour rather, that's going to be equal to the initial amount, which is 1,200, plus all the water which is coming in, which is the integral from 0 to 18 of w of t dt, and then we need to subtract all the water that's going out, which is the integral from 0 to 18 of r of t dt. And we actually could put this together as one integral, since the bounds are the same. We could have the integral from 0 to 18 of w of t minus r of t wrapped in parentheses dt. That would be fine as well. So we bring in the calculator. I'm going to slide this over slightly. There we go. We bring in the calculator. You can see we have the two functions. W is located in y1 and r is located in y2. So we'll go to the main screen, clear that out. We have 1,200, and we are going to add in the integral, so that's math option 9, and we're going from 0 to 18, and I'm actually going to do what I just mentioned. I'm going to put in do y1 first, and then we're going to subtract y2. We could do this as two integrals, but we'll just do it as one integral with subtraction in the integrand, and we need our dx, and we'll hit enter, and give it a second to think. And it's going to come back with 1,309 gallons to the nearest whole number, so we can round that up to 1,310 gallons. And we have our solution. Question number 5. For the domain of t between 0 and 31, we have mosquitoes on this island, and the rate of the mosquitoes' population is changing at 5 times square root of t cosine t over 5 mosquitoes per day. We're starting with 1,000 mosquitoes on the island at t equals 0, and according to the model, how many mosquitoes are we looking at for time t equals 31? Okay, so just like before, initial condition, which is 1,000, plus all the change. So our initial time is 0, our ending time is the 31st day, and r of t is the rate at which the mosquitoes are changing. So bring the calculator back in, and we have the mosquito rate there in y1. So we go to the main screen, and we have 1,000 plus math 9. Bounds are 0 and 31, and y1 is our rate. It's in terms of x, so we have dx. And we see there, come on, take its sweet old time. We're looking at 964.335 mosquitoes. And it says round your answer to the nearest whole number, so we can just say that is approximately 964 mosquitoes. Alright, and finally we have water being pumped into an underground tank at a constant rate of 8 gallons per minute. And it's leaking out of the tank at a rate of root t plus 1 gallons per minute, and the bounds are 0 to 120 minutes, and then there's 30 gallons of water, at time t equals 0. So how many gallons of water leak out of the tank during the first 3 minutes? Okay, so we are looking at the integral from 0 to 3 of the rate at which the water is leaking out, which is the square root of t plus 1. Now we have to show the work that leads to our conclusion here, so this one has to be done by hand. So we're going to have t plus 1 to the 1/2 power, because that can actually be anti-derived, since we actually have an inside function to the 1/2 power, but that inside function, if we were to make this u, u would be t plus 1, and the derivative of t plus 1 is just dt, so we don't need to make any changes. We don't really need to use u substitution here. We can just go right through our fundamental theorem of calculus. So we're going to anti-derive t plus 1 to the 1/2 power. That will become t plus 1 to the 3/2 power over 3/2, which will be evaluated from 0 to 3. Now we can simplify this a little bit so that we can plug in our numbers 3 and 0. So if we're dividing by 3/2, that means we're really multiplying by 2/3. So we've got 2/3 here. And then we have t plus 1, that quantity to the 3/2 power. Well, the 2 in the denominator of the exponent means we're taking the square root, and the 3 in the numerator means we have t plus 1 being cubed. So that's a lot easier to plug 0 and 3 into, and we're going to plug 3 into first because that's what our fundamental theorem of calculus says. So we have 3 plus 1, which is 4. 4 cubed is 64. So we have 2/3 times the square root of 64 minus, now we'll plug in 0. And if we plug in 0, 0 plus 1 is 1. 1 cubed is 1. The square root of 1 is 1. So we have 2/3 times the square root of 1. So square root of 64 is 8. So we have 8 times 2, or 16/3, minus square root of 1 is 1, times 2, so minus 2/3, for a total of 14/3 gallons. And that is our answer for the amount of water that has leaked out of the tank. So we can see there's just under 5 gallons of water during those first 3 minutes. Okay, so how many gallons of water are in the tank at time t equals 3 minutes? We're going to justify our answer. So what do we have? We have 30 gallons of water that were in there initially, and we're losing 14/3 total. We've already figured that out. And then we are looking at a constant rate of 8 gallons per minute being pumped in. So 3 minutes, 8 gallons per minute. So we're adding in 8 gallons per minute for 3 minutes. So what do we have here? Well, we have, we can leave our answer like that. First of all, that's a correct answer. Just put gallons in there. But if you want to simplify this, 30 is 90/3. So we have 90/3 minus 14/3. And then 24 is 72/3. So 90 minus 14 is 76. 76 plus 72 is 148. So we have 148/3. And we can see there's just below 150 there. So we're looking at just under 50 gallons.